Hi everyone, I'm Ahad. Today I'm gonna explain a recent project of supervised classification for land cover land use with the help of Google Earth Engine. So let's get started. So do the supervised classification, we have to use the Landsat 8 imagery. We have to first of all collect the data. We can see that we have to use the image collection for Landsat 8 with tier 1 and the special filter for our study area and the temporal filter for given time for our LULC map. We can change this data for year to year to determine the LULC map here. And the cloud cover is less than 1%, which help us to classify the image more better, and the processing for mean of all this data and keep the study area from the final composition. Here the training sample. In this training sample, we can see that we have to train the sample with water data, vegetation data, agricultural built up, and the barren land data. We have to merge all these individual layer into a single layer and name them as property with land cover, and the scale will be 30 meter. So here in the classification process, we have to use the algorithm of smile card where we can train the classifier for the image generation for supervised classification and visualize the data, and furthermore export the data from the Google Earth Engine to our required application like ArcGIS Pro for map layout. Here is the Google Earth Engine code for our LULC supervised classification. So first of all, we have to import the study area. I had the shapefile of the study area, so I have imported the shapefile here. And now we have to select the date for which we want to do the LULC supervised classification. First of all, we have to declare a variable which is for the Landsat data. So here we have used image classification for the Landsat 8 data, and then we have used filter bound for our study area. So in the study area, we can see that this is the Lalmonihart study area. I have changed the name of this variable to ROI. So we have called the filter bound as ROI to filter out the study area from the Landsat image. We use the filter date here, so we can have the range of the date we wanna classify the image with. You can always change the year so that you can have year-to-year LULC data. Now I have used the filter metadata for cloud masking as a band tag for cloud cover from the Landsat data. This cloud masking help us to select the Landsat image which have less than 1% of cloud. The mean function composites all of the Landsat images that have been gathered from all this code and clips the ROI, our study area, from the mean composite layer. Now I have to give some training data to classify the image with the ground point and the image. So here is the all the classification data. If we run this code and select the satellite base map, we can create the training data from the satellite images. For example, to create the training data, we have to go to geometry and new layer. If we select a new layer, go to the setting, and from this drop down, select feature collection. We want to create a collection of features from the satellite image with given values. So after selecting it, we have to go to the properties, and here we have to type a variable name like LC and the value of the property here like 1 and create this. Now we can scroll through the satellite image here and select the water data. Here it has been selected, and create some training point which indicates the water. Following these steps, we can create water data, vegetation data, agriculture data, built up data, and barren land data. The large amount of dataset from this training point, with an increasing value, we can have the supervised classification more accurately. I have taken almost like 300 of each data from here for each variables. I have used the vegetation here and created some vegetation training data. We have to remember this carefully that in the feature collection for this every variable, we have to give the property name as LC, because in the furthermore, call the LC value for each variable and create some training principles with it. I have given each value a name and same property with different kinds of value that indicate different kinds of raster files like water, vegetation, and other properties here. Following these steps, we have to create all these variable, all these training data for each individual labels we want to see. After that, we have to create training points. The variables here are all individual. They are separated in different layers. We have to merge them in a single layer. So in this training point variable, we call water and merged every single one of them using merge function. This extracted all the pixel values from the image using all the training point we have created. This initialize a card, which is a decision tree classification function, which help us to classify all the other training point based on the given actual training point with help of cloud computing. In this line, we have to train the classifier with all the band that are available in the Landsat 8. We know that in Landsat 8 there are 11 band 1 to band 11. So we have to use all this band with help of our LC property, which are the training data we have given in the value property name, and create a classifier variable here. After training the classifier with the given training data with help of the spectral band, this line of code, which is classified image variable, applies the train classifier to generate land cover map. The most amount of time we have to carefully give in this project is to train the model. The more amount of classifying, the more amount of training point actually and accurately given to this data set, the more accurate will be the supervised classification would become. Our supervised classification is almost done with this line. So we have to visualize the supervised classification image. In this variable for classified image, all the label for the land use land cover are given respected colors here. We use the map 8 layer to generate the map in this layer tab and export it if we want to use, and create LULC map in other programs if we want. So now if we run this code, control enter and scroll a little bit, the supervised classification is here. So if we select the satellite image and scroll here, this urban area is colored as red. There is some barren land, and we can see that here is a river that goes through here, which is depicted here with agricultural lands and other vegetations. So this is our supervised classification map at a scale of 30-meter resolution.